Hi everyone. In this video I'm going to show you how you can test a second order CFA model using the Amos program. And before we get started, I should note that this video is designed to accompany a PowerPoint presentation that I've put together on this topic, and you can obtain a copy of that PowerPoint by following the link that's provided underneath the video description. Additionally, under the video description you will find a link to the SPSS data file that I'm working from throughout this presentation, so you can download that data to follow along. Now, second order CFA can be used to test the assumption that the correlations among a set of first order factors is accounted for by one or more higher order factors. In the pictures below, or the diagrams below, you'll see we've got two different CFA models represented. On the left we have a first order CFA model where we have basically four factors that are represented, and then the double-headed arrows among all of them indicate that those factors are being modeled as being correlated or are all intercorrelated. On the right we have a second order CFA model where those double-headed arrows have been removed from the first order factors, and what we have are second order factors that are being modeled as a way of accounting for some of the associations among the first order factors from the first order factor model. So in his text, Timothy Brown provides a general strategy for testing second order factor models. Step one is to develop a well-behaved first order CFA model that also makes sense from a conceptual standpoint. Step two is to evaluate the correlations among the first order factors to determine whether it is reasonable to suppose a second order factor may be producing the associations among the first order factors. And then step three is to test the fit of the higher order factor model and evaluate its conceptual validity. And I do note that not everyone necessarily follows all three of these steps, but this is a nice logical progression that I wanted to share with you in this video. So let's briefly talk about the variables in the model specification. So basically the boxes that you see in this diagram are representing items from a coping styles questionnaire. And you can see that we have three items that are loaded onto each of the first order factors. So the first order factors that are being represented right here include problem solving, cognitive restructuring, express emotion, and social support. And so you can see that the single-headed arrows from the first order factors to the individual items, those are going to capture the factor loadings. But you'll notice that for each factor there is one loading that is fixed to 1, and this is designed to scale the latent variable or our latent factors. You'll also see in our diagram that we have our second order factors that are represented, and as I was noting before, we are specifying these as possibly accounting for the some of the first order associations, or the associations among some of the first order factors. So here we have problem focused coping and emotion focused coping as second order factors. You'll also notice that we have single-headed arrows from the second order factors pointing to the first order factors, and again I've fixed one factor loading in each of these cases to 1 in order to scale the second order factor. But another possibility is to fix the variances of the second order factors to 1. That's another option as well. One other thing to note here too is that we have an error term associated with each of our first order factors, and that's reflecting the variance that's unaccounted for in the first order factors by the second order factors. And really briefly, this is the layout of our data in SPSS. This was actually summary data that's presented in Timothy Brown's book, so I've just kind of set this up in SPSS. So you can see that I've got P1 through P3. Those are those problem solving items. C1 through C3 are the cognitive restructuring items. E1 through E3 is the express emotions items, and then the S1 through S3 are the social support items. So basically it's set up where we have a correlation matrix for all of the items, as well as we have down here a row of standard deviations for the items, and also the ends for the items. As I said before, this is just basically summary data, and this is perfectly permissible to import into Amos and to run a model, although most of the time when people are running analyses using Amos, they'll probably be using raw data. Okay, so with our steps 1 and 2, we're just going to kind of combine them. These are going to entail specifying and testing the first order factor model, and then also evaluating the correlations among the factors. So when we do this, we're going to want to make sure under analysis properties to select standardized estimates so that we can get those correlations. So what I'm going to do is go ahead and open up SPSS and walk you through the model specification so that it looks like this. This is a first order factor model where all of our first order factors are specified as being intercorrelated. Okay, so here we are in Amos, and what I'm going to do is I'm going to draw out the model, and I'm going to first go over to view and interface properties. I generally like a little bit more drawing space to work from, so I'm going to go ahead and go into interface properties, paper size, kind of expand that a little bit. So when I go over here, I'm going to click on draw observed variables, and I'm going to click that box, and it's just a little button, and I'm going to draw out just a little rectangle right here. And I could do that for each of the individual items, but I'm going to kind of expedite things through a little short-term, a little bit shorter strategy, if you will. So I'm going to click off of that box and go over here and click add a unique variable to an existing variable. So I'm going to click on that, and now you can see that I'm drawing out a uniqueness associated with that item. So I can actually move this around, and there you go. So now we have one item and one uniqueness that is drawn out. So again, in order to expedite things, what I'm going to do is click off of that box, and next I'm going to click on select all objects, so everything appears in blue. And I'm going to use this little photocopier right here to draw out the 12 items and their associated measurement errors. So there's 4 right there, and I'm going to pause this and finish this out just to kind of keep things running along. Okay, so I've drawn these out, and I'm going to go over here to deselect all objects, and so now everything turns back to the original color. And I'll go ahead and draw out my 4 first order latent factors. So I'm going to click on this draw observed variables box right here, and you can see that I can just draw this out. I'm just going to there's the first oval for the first latent factor. And again, to kind of expedite things and also kind of keep things proportional, I'm going to use this little copier here and click on that, and so I can drag out these other ovals right here. Alright, so there's that, and I might as well just go ahead and draw in the second order factors. Well, actually, we're starting off with that first order factor model, so ignore that. Okay, so now what I need to do is to bring the variables, the observed variables, into these boxes. So that means I'm going to need to import the data. So what I'm going to do is to go over to select data files and click on file name, and I'll go ahead and click on the data file right here, click open, and then OK. And so you can see really quickly that the data file is being imported. So I'm going to click on that, OK. And so now I can go ahead and assign variables to each of these rectangles. So I'll go to list variables and data set right here, and I'll move the there's the P1, P2, P3 over. Then we have C1, C2, and C3. And then I've got E.1, E.2, and E.3. By the way, the E.1, 2, and 3, the reason why it's not just E1, E2, and E3 is because I typically name the errors E1, E2, and E3, and so that would obviously create a little bit of a problem in terms of running the model because the program wouldn't be able to distinguish between the errors and the variables. So that's where the E dots are coming into play. Then there's S1, S2, and S3 right here. So next what we'll do is we'll go ahead and name our latent factors. So I'm going to right click on the first one, go to Object Properties right here, And we'll go ahead and under variable name, we'll type in prob.solve right there. So there's the first one. For the second one, I'll click down here. For the variable name, it'll be cog.rest for cognitive restructuring. The third one is express emotion, so exp emote right there. And then we have social .sup for social support right there. And by the way, the naming is completely arbitrary. So next I'm going to go ahead and name the measurement errors over here. So I'm going to click up on this first button right here for P that's associated with P1, and I'll just call this E1. Then we have E2, E3, and so forth. So I'm going to pause this really quickly and finish that out. Okay, so now we have our error terms all named, and so the next thing we're going to do is go ahead and specify the relationships between each of the indicator variables and their respective latent factors. So I'll go ahead and click on this arrow button right here and then draw out the first three arrows right here, and so that's for problem solving. And then we'll draw out the next three for cognitive restructuring. So there's the C1, C2, and C3. Then we have the express emotion indicators right there. And then we have the social support indicators right here. So at this point, we can move things around too if we want. We can use a little moving truck guy and kind of reorient things a bit if we want to do that. So I'm going to click off of that. Now I need to fix one of those loadings to 1. That's how I'm going to scale the latent variables. So I'll just go with the first item, the loading associated with the first item for each kind of subscale. So I'll go to Object Properties, click on Parameters, and then type in 1 for the regression weight. We'll do the same thing right here as well as here, and then down here as well. And then the next step is going to be to draw in the correlations among the latent factors. So we'll go ahead and do that. So there's problem solving and express emotion, problem solving and social support, cognitive restructuring and express emotion, cognitive restructuring and social support, and then emotional or express emotion and social support. So now we've drawn in our correlations among the latent factors. So the next step that we want to take is to go under analysis properties, and just kind of FYI, if you're working with actual raw data and there's no missing data, then you don't need to do anything on this particular under this particular tab. But if there is missing data, you're going to need to click on estimate means and intercepts. In this case, I don't have missing data, and obviously I'm working with summary data anyway, so there's no need to click on that. Under the Output tab, I'm going to go ahead and click on Standardized Estimates. If you want the squared multiple correlations, basically, or communalities, we can click on that as well to get that in our output. Okay, so the next thing is to run the model. So I'm going to go over here and click on Calculate Estimates, and it's probably going to ask me to save the file. So I'm going to click on that, and we'll just call this demo. Actually, I'll save over a previous demonstration, so I'll click on demo right there and save that over that. So there you go. And so now the analysis is run, and when I click on this little tab right here, you can see that we have the unstandardized estimates represented first, and then the standardized estimates are represented next. And so as you're looking at this, you can see first off that with respect to the factor loadings from the standardized estimates, basically these are all going to be correlations between the latent variable and its respective indicator variables. So all of these correlations are really high. These are really high correlations as well. The same goes here and here as well. So you can see that the indicators are very well related to the proposed latent constructs that they're measuring. Then you can see, looking at the correlations, you got problem solving and cognitive restructuring. This is the correlation between the two. It's 0.66. The correlation between emotional expression and social support is 0.67. and then you can see that the remaining correlations between, say, problem solving and emotional expression and social support, both of those are basically 0.20. You can see between cognitive restructuring and the express emotion and social support, those are also 0.20 correlation. So those are very small, and so the differential pattern of associations that we see among those latent variables suggests the possibility that there may be second order factors that could account for some of those associations. And then briefly, let's just go under the output right here and just take a look first off at the model fit. You can see that the chi-square goodness of fit test is statistically significant, so we would reject the notion that the model is an exact fit to the data. Nevertheless, we do see that the GFI and AGFI, those values are above 0.90, suggesting acceptable to good fit. We also have the TLI and CFI. Both of those values are quite high, indicating good fit of the model to the data. And then we also have our RMSEA of 0.051, and then our non-significant P-closed test. Both of those are indicating a well-fitting model. So I actually spend a lot more time in the PowerPoint going over the criteria for evaluating those. So I know I kind of brushed through these here in the video, but you can check out the PowerPoint discussion of those if you want further clarification. Then just really quickly, we'll go under estimates right here. You can see that we have our regression weights. These are the unstandardized factor loadings, and you can see the ones are representing those loadings that were fixed to 1. Then you can see we have our standardized factor loadings basically right here. And then finally we have our covariances among the first order factors, and then if you wanted the actual correlations, that's these right here, and we've already kind of talked through these when we were under the graphical interface. Also, finally, we'll kind of scroll down just a bit here, and you can see we have the squared multiple correlations associated with each item, and basically these are the communalities. So they're essentially representing the proportion of variation in each of the individual indicator variables that's accounted for by their respective factors. Really quickly too, one other measure of fit that sometimes folks would like to have is the standardized root mean square residual, and that's not available through the standard output, under the model fit output, but you can obtain it if you use the plugin. So there's a plugin up here. You can go there, go to standardized root mean square residual right there, and if you run the model with this box open, it's going to generate that value. Just kind of keep in mind though that this only works if you have complete data or you're working from summary data like I'm doing in this case. So if it's the case that you have missing data, then you're not going to be able to generate that piece of the output. So at any rate, let's go ahead and respecify this first order factor model so that we incorporate our second order factors. So what I'm going to do is go ahead and I'm going to remove each of these double-headed arrows right there, and like I said, we're going to assume that two factors account for the main associations among the first order factors. So what we'll do is we'll go ahead and just use our little copier right here. I'm going to create a second order factor right here and a second order factor right here, and the next thing is we'll kind of deselect this, and we're going to right click and rename the second order factors. So I'm going to go under object properties, go back to text right there, and basically instead of the prob solve that we had, we'll just call this prob FOC for problem focused coping, and then we'll come down here, and then for this one we will call this emote FOC for emotion focused coping. And then next up we will draw in our arrows from our second order factors to our first order factors. So problems focused coping is being modeled to account for the correlation between problem solving and restructuring, and then emotion focused coping is being specified to account for the association between express emotion and social support right there. Next up, we will go ahead and use our double-headed arrow to create the correlation between these two types of coping, or general coping approaches. And then last, we need to scale those second order factors. So what we're going to do is I'm just going to go ahead and use fixing one of those factor loadings from each of the second order factors to the first order factor to 1. So I'll start with this first one right here. We'll go ahead and go under parameters. The regression weight, I'll fix that to 1, and then we'll do the same thing right here and fix that to 1. So now we have our second order factor analysis model fully specified. And I'll go ahead and just save over the other one, and now we can rerun our analysis with this particular model. So we'll go ahead and go to calculate estimates right here, and you'll notice that I made a little bit of an error because I forgot to incorporate the error terms associated with those first order factors. So what we'll do is we'll cancel that analysis and we'll add in those error terms. And you can see that the more complex a model becomes, the easier it is to forget something, and so I just did that. So at any rate, I'm going to create disturbance terms for those first order factors, and let me kind of reorient this just a whisper there, and we'll do the same thing right there. So what I'll do is I'll right click in this circle, go to Object Properties, and I'll go ahead and go under Text, and I'll name this ERR1, and then we'll do this one, we'll name this ERR2, then ERR3, and then ERR4. And so now this should work out. So we'll kind of resave this and run our analysis. And so now it works out perfectly, and we'll go to kind of go under this tab right here and take a quick look. Under the standardized estimates, you can see that the factor loadings, again, our first order factor loadings, those are all quite high, signifying strong relationships between our manifest indicator variables and those first order factors. But we also see that the correlations between the first order factors and the second order factors are also quite high. So these first order factors are serving as good indicators of those second order factors. But we do see too that the correlation between the second order factors is quite low. So at any rate, this is our second order factor analysis model. Again, right now these are all the standardized estimates. If you wanted the unstandardized, you could just click right there to go to those. At any rate, let's go ahead and take a look at the overall model fit. So I'm going to go under this box right here and model fit. And you can see that the chi-square value is 82.703, and this model is also statistically significant. So we would reject the notion that the model is an exact fit to the data, but nevertheless you can see that the CFI, TLI are both high, again indicating good model fit. GFI and AGFI are also indicating good fit. When we scroll down, the RMSEA is 0.05. Our P-close test is 0.474. Those are all indicating good fit. Now, it is important to note, though, that when we moved from the first order factor model to the second order factor model, that basically the first order model imposes fewer constraints than the second order model. And so our expectation is going to be that the first order model would fit better than the second order model. And when you looked at the chi-square value from the first order model and then looked at it for the second order model, you can see that the chi-square value for the second order factor model is higher than that for the first order model. And you can also see the degrees of freedom is 49, whereas the degrees of freedom for the first order model was 48. So in this particular, basically In the first order model, we're estimating one additional parameter than we are in the second order model. Now what we would want to do is to test whether the second order model, the decrease in fit, is statistically significantly different from that of the first order model. And if it's not, then what we would want to do is to maintain the second order model because it's a more parsimonious representation of the data than the first order model. So to test this out, we can utilize the chi-square difference test, where basically we take the chi-square values and the degrees of freedom from both models and carry out the test. So you can see right here that I have output from both of the models. From the first order model, this is the chi-square value of 82.668. For the second order model, it's 82.703. And just keep in mind that the model with the higher chi-square value is theoretically fitting worse than the model with the lower chi-square value. But again, we're wanting to test whether there's a significant decrease in fit of the second order model relative to the first order model. You can see there's our degrees of freedom for the first order model and the second order model. Degrees of freedom for the first order model is 48, for the second one is 49. So the chi-square difference test is just computed, the chi-square difference value is computed by taking the chi-square value from the second order model and subtracting the chi-square value from the first order for the first order model, and that difference is 0.035. The degrees of freedom for our test is just simply computed by taking the degrees of freedom from the second order model and subtracting the degrees of freedom from the first order for the first order model, and in this case then we have 1 degree of freedom. So we can we can actually carry out the test in a couple of ways. You can look in the back of many stat textbooks and you'll find tables of chi-square values for say alpha at 0.05 or 0.01 or whatever, and given certain degrees of freedom. So basically for a chi-square test with 1 degree of freedom and testing with alpha at 0.05, the chi-square critical value is 1.84, and you can see then that the 0.035 that we have in our data, or that's computed from our data, is way less than the 1.84. So that would tell us that there's not a statistically significant difference between our first and second order factor models in terms of their fit. Now if it's the case that you would like to obtain a p-value for your chi-square difference test, you can actually, there's a number of websites online where you can compute them for a chi-square distribution. So I've actually provided a link in the PowerPoint, so I'll just briefly click on that and take us to one. So this is it right here. You can see the chi-square value is 0.035. That's the difference value, and then the degrees of freedom is 1. And the significance level we'll just leave as set at 0.05, and so when I click on calculate right here, you can see that the p-value for this chi-square difference test is 0.851596. So again, it just basically says right here, it says the result is not statistically significant at p less than 0.05. Okay, so that pretty well rounds out this discussion and demonstration, and I appreciate you watching.